everyone, myself Bhavana. Today me and my team members are going to discuss about loan eligibility prediction. Where the agenda of this video is about loan eligibility prediction, what is data science, what is machine learning, types of machine learning, algorithms used in the project, why Python, libraries used in the project. About loan eligibility prediction. Loan eligibility prediction refers to the process of assessing the likelihood that an individual will approve for a loan by financial institution or lender. This prediction is typically made using statistical or machine learning models that analyzes various factors and criteria associated with the applicant's financial profile. The goal of loan eligibility prediction is to help lenders making informed decisions about whether to approve or deny loan applications by analyzing historical data on loan applications and outcomes. Predictive models can identify patterns and relationships that indicate the likelihood of repayment or default. About loan eligibility prediction. So what are the criteria of loan eligibility prediction? Loan amount. Loan amount should be mentioned in the application. Applicant income should be mentioned, gender of the applicant, dependents of the applicant, loan amount, term, credit history of the applicant, marital status of the applicant, co-applicant income, property area. These all the criteria should be mentioned in the application. What is data science? Data science is the domain of study that deals with the vast volumes of data using modern tools and techniques to find unseen patterns, derive meaningful information, and make business decisions. The data science uses complex machine learning algorithms to build predictive models. The data used for analysis can come from many different sources and presented in various formats. What is machine learning? Machine learning is a branch of artificial intelligence that develops algorithms by learning the hidden patterns of the datasets, used it to make predictions on new similar type data. Without being explicitly programmed for each task, traditional machine learning combines data with statistical tools to predict an output that can be used to make actionable insights. Machine learning is used in many different applications, from image and speech recognition to natural language processing, recommendation systems, fraud detection, portfolio optimization, automated tasks, and so on. Machine learning models are also used to power autonomous vehicles, drones, and robots, making them more intelligent and adaptable changing environments. Loan approval prediction using machine learning. Loans are major requirement for modern world. By this only banks get a major part of the total profit. It is beneficial for students to manage their education and living expenses and for people to buy any kind of luxuries like house, cars, etc. But when it comes to deciding whether the applicant's profile is relevant to be granted with a loan or not, banks have to look after many aspects. So here we will be using machine learning with Python to ease their work and predict whether the candidate's profile is relevant or not using key features like marital status, education, applicant income, credit history, etc. The next part will be continued by my friend Bhavana.
Types of machine learning. In loan eligibility prediction, various types of machine learning techniques can be employed depending on the complexity of a problem and the nature of the data. Some of the common types of machine learning used in this content include supervised learning, classification. This is most common approach where historical data with a labeled outcomes is used to train a model to classify new loan applications into these categories. Algorithm like a logistic regression, decision tree, random forest, support vector machines, and neural networks can be used for classification tasks. Semi-supervised learnings. In scenarios where labeled data is limited but enabled data is abundant, semi-supervised learning techniques can be used to leverage both types of data. Technical like a self-training, co-training, and labeled propagation can be applied to make a predictions on a enabled data while utilizing a limited labeled data for model training. Unsupervised learning. In this unsupervised learning, clustering will be coming. In clustering, unsupervised learning techniques such as clustering can be used to group a similar loan applications together based on their characteristics. This can help in identifying the patterns or segments within the data, which may provide a insight into a potential eligibility criteria or a risk assessment. Deep learning. In deep learning, techniques such as a neural networks with a multiple hidden layers can be applied for loan eligibility prediction when dealing with a large complex data sets. Deep learning models can automatically learn intricate patterns and relationships in a data, potentially leading to improved predictive performance. However, they often require a significant amount of data and computational resources. Next one is unassembled learning. Unassembled learning methods such as a bagging and boosting can be used to combine a multiple base models to improve the prediction accuracy. Techniques like a random forest and gradient boosting machine are popular ensemble methods that can be applied to a loan eligibility prediction target. Reinforcement learning. While less commonly used in loan eligibility prediction, reinforcement learning techniques could be explored in a scenarios where decision needs to be made sequentially over time. For example, in dynamic loan approval process where decision may be influenced by changing a market conditions or browser's behavior. Supervised learning. Machine is trained using a label data. The algorithm learns from a label training data and predicts the outcome of the unseen data, the algorithm. Several algorithms are commonly used in loan eligibility prediction tasks. Here are some of the most popular ones. Logistic regression, a simple and widely used algorithm for a binary classification task like a loan eligibility prediction. In model, the probability of binary outcomes based on one or more predictive variables. Decision tree. Decision tree recursively partitionate the feature space into a subset, making a decisions based on the value of each feature. They are interpretable and can handle both numerical and categorical data. Random forest, a powerful ensemble learning method that construct a multiple decision tree during a training and output the model classes or mean prediction of a individual trees. Gradient boosting machines. The gradient boosting machines sequentially builds a weak learners and combines them to improve a predictive performance. Support vector machines. The support vector machines construct a hyperplane or a set of hyperplanes in a high dimensional space to separate a classes. It's effective in high dimensional spaces and when the number of features exceeds the number of samples. Naive Bayes. Despite its simplicity, naive Bayes is often used for loan eligibility prediction due to its efficiency and ability to handle a categorical data well. It assumes independency between features which may not always hold true, but it still performs well in practical for this task. The next slide will be handled by my friend Danush.
Algorithms. Neural networks. Deep learning techniques such as artificial neural networks can be applied to loan eligibility prediction tasks, especially when dealing with complex nonlinear relationships in the data. Architectures like feed-forward neural networks, convolutional neural networks, and recurrent neural networks can be utilized based on the data characteristics and requirements. Regressions. In loan eligibility prediction, regression analysis can be used to predict continuous outcomes related to loan application, such as amount of loan that can be approved, the interest rate that will be offered, or expected default probability. There are few common regression techniques used in loan eligibility prediction. One is linear regression. Linear regression is a straightforward approach where the relationship between input features such as income, credit score, etc., and the loan outcome between his model given in a linear equation. The model predicts a continuous outcome, making a suitable task like predicting loan amounts based on applicant characteristics. Next type of regression is multiple regression. So multiple regression extends linear regression to incorporate multiple input features simultaneously. It models the relationship between multiple independent variables and a dependent variable, that is loan outcome, and allowing for more complex predictions based on multiple factors. Logistic regression. Although logistic regression is typically used for binary classification tasks, it can also be adapted for regression tasks related to loan eligibility prediction. For example, logistic regression can be used to predict the probability of loan default based on applicant characteristics. This probability then be used as continuous outcome in a regression context. Next, attribute selection measures. In low eligibility prediction, attribute selection measures are used to determine the importance of features, that is, attributes, in the dataset, helping to identify the most relevant factors for making accurate predictions. Some common attribute selection measures used in the context include: first is information gain. So the information gain is a measure of the reduction in entropy achieved by splitting the data on a particular feature. Features with higher information gain are considered more informative for predicting the target variable. So next is gain ratio. The gain ratio is a variation of information gain that takes in an account the intrinsic information of a feature. It penalizes features with many distinct values, favoring features that result in a small number of evenly distributed subsets. Next, Gini index. The Gini index measures the impurity of a dataset by calculating the probability that a randomly chosen sample from the dataset is misclassified. Features with lower Gini index values are considered more important for splitting the data. Next, attribute selection measures. So there are chi-square tests. So chi-square test means it measures the dependence between two categorical variables. It evaluates whether there is a significant association between a feature and a target variable. Features with target chi-square values are considered more relevant. Correlation. The correlation measures the strength and direction of the linear relationship between two continuous variables. In loan eligibility prediction, correlation analysis can help identify features that are highly correlated with target variable and therefore may be important for the predictors. Next, attribute selection measures. So what are the attribute selection measures? First is wrapper methods. Wrapper methods assess the predictive performance of feature subsets by evaluating different combinations of features using specific machine algorithm. For the example, forward selection, backward elimination, and recursive feature elimination. Next, embedded methods. Embedded methods incorporate feature selection within the process of model training. For example, decision tree based algorithms like random forest and gradient boosting machines naturally perform feature selection as a part of tree building process. Naive Bayes. So naive Bayes is commonly used in loan eligibility prediction because it's a simple and efficient classification algorithm that works well in categorical data. In this context, it can analyze various features of loan applications such as income, credit score, employment status, and etc. and predict whether they are eligible for a loan or not based on historical data. Naive Bayes assumes that features are independent, which might not always hold true but still tends to perform well in practice in their task. So thank you. Next slide will be continued by Gagan Nayak KM.
Thank you, Dhanush. Next, you will discuss about assumption made by Naive Bayes. Independence of future. Naive Bayes assumes that all futures are conditionally independent and given in the class level. In other words, in presence of value, the sum of future does not depend upon presence or value of another future, given whether applicant is approved or declined loan. So this assumption simplifies the calculation of probabilities, makes the model and computation is efficient. Normality of continuous future. If using Gaussian Naive Bayes for continuous features, it assumes that the distribution of each continuous feature given at the class level in Gaussian or in normal. So this assumption may not hold the true continuous features in low eligibility predictions, but in Gaussian Naive Bayes, it can still be effective. It can data approximately follows as a Gaussian retractions after the approximate transformations, or it assumption is not strictly enforced. Next, we want to discuss about assumption made by naive. So, categorical or distract features. So, it directly uses the observed frequencies of a different categories or the features in each class of compute responsibilities. Presence of sufficient data. The naive Bayes assumes the availability of sufficient training data to accurately estimate the probabilities made by or classification of insufficient data can be relatively lead to unreliable probability of estimates and impact on model performance. And next, equal importance of future. The Navi bias treats all futures equally in important in predicting the class level. Next is class balance. The Navi bias assumes that the class are balanced or the class distribution representative or underlying the population. Why is Python code used in loan eligibility prediction? The Python is widely used in loan eligibility prediction due to the rich ecosystem of libraries and tools of data analysis and machine learning of model deployment and some other key uses like Python in a context included. So data processing. Python libraries like Panda and NumPy are used to clean the pre-process and transform the raw loan applicant data into the format suitable for analysis and modeling. So machine learning model. Python provides a process that popular machine learning libraries such as TensorFlow and PyTorch, so which offer various algorithms and techniques for building predictive models. So Navi-based and decision trees and random forest and logistic regressions and neural networks are among the algorithms commonly is applied to the loan eligibility prediction tasks. And next is model evaluation optimization. So Python libraries enables the evaluation of model performance using matrices such as accuracy, precision, recall, and FI sources. The next is deployment and integration. Python frameworks like Flask and Digno facilitate that the development of machine learning models as a web service or APIs allow the lenders to integrate the predictive capabilities into their existing systems and or applications. Libraries used in project. So like several Python libraries are commonly used in low eligibility prediction tasks. Some of key libraries are pandas and numpy. So pandas are used for data manipulation and analysis. So numpy is used for numerical computing in Python. Next, the libraries used in this project are skitlearn. That is, skitlearn is a powerful library for the machine learning in Python. So it provides a wide range of algorithms for classification, regression and clustering, and dimensional reduction. Next is TensorFlow or PyTorch. So these libraries are used in for building a training deep learning models. Next is Seaborn. So these libraries are used for data visualization in Python, and they allow to create the various types like plots and charts to explore the understand your data. Like Flask means the web framework are used for building the web application and APIs. So thank you guys for watching this video. Please like, share, and subscribe. So see you soon in the next video.